I'll just run through a bit about myself. I'm Steve Mugglestone, the Engineering and Operations Manager for Railcare Sweden Limited. My career started back in the late 80s, 87. I started as a trackman in Tamworth, and I've been a maintenance man for most of my career until the Railvac landed on my desk as a project manager in Carillion. And since 2004, early 2005, I've been working with and promoting the Railvac for in-situ re-ballasting and any other excavation works. So that's a little bit about me. And the agenda, I'll just give you a quick introduction about the Railcare Group, who we are. A little bit on the Railvac route system compared to the fan systems. We use a different system for creating our airflow than a fan. And then the Railvac and the BFS is the ballast feeder system. I can talk through the machines there. And one of the important things is the engineering quality that we should come to expect from the Railvac and the people who work with the Railvac, the engineering guys on site, the STOs, the TOs, etc. And then some more on the versatility and the opportunities for Network Rail. Finally, the summary. And again, if you want to ask a question as we go through, then please feel free. It's hopefully you'll find it enjoyable, and we'll carry on from there. Thank you. So Railcare, we're a Swedish company. We've got a UK office here in Derby, and we've been here since, like I said, 2004 with the Railvac, when it landed on my desk at Carillion, and somebody says find a job for it, find out the process, how to work with it, etc. And since then, Railcare built the OTM machines since 1992. We've got them all over the world, 60 plus machines. The machines we have specifically for the UK are W6A machines, gauge, so we can work anywhere on Network Rail infrastructure, apart from a few areas such as bay platforms or where the gauge is tight for everybody to use. And we have the ballast feeder system. Again, that's fairly new, probably four years been in the making, and now available in the UK. We are corporate sponsors of the PWI, and as it says there, we share its aims, that's for sure. And basically, that's what we are. We're an innovative company that develops new solutions for lots of our clients, including Network Rail and LUL. We have machines on LUL as well that we develop for the tunnels, smaller machines. So firstly, how does the roots compressor system compare to fan systems? A fan system, I won't go through it too quickly. It's not my forte, as it were, but I can send you over a copy of this for you to sort of read through. So, but basically, a fan system, it uses the auxiliary system on a truck PTO, a power takeoff from a truck, mostly road rail version. Well, nearly all of them are road rail versions, and that powers 2, 3, 4 fans, and it's the fan that generates the airflow through there. So, and it consumes, as it says there, consumes the most energy when the suction line is open. So as soon as you block the system, the power dies down. The root system, it's a big, we have a big rotor inside, 2 big rotors inside like a hydraulic pump, and it's turned by a marine engine, cat marine engine. So we have an engine to move the machine up and down on the track, and we have a single engine to generate the airflow. And it's 2 intertwining rotors spin very, very fast. That creates the airflow. And if you block the nozzle on this, it builds up the pressure. And again, so when we compare the roots compressor to the fan systems, the root compressor generates 0.93 of a bar, 93% vacuum. That's massive power. So we have to install a safety valve, and we knock it down to 0.8 of a vacuum, 80% vacuum. So the filter hoppers and and everything doesn't get all sucked in. I don't know what's happened there. We've gone back for some reason. And again, I won't read all this to you, and I know it can be a bit boring reading text off a presentation, but you'll get this presentation, like I said, so you'll be able to read through it at your leisure. They're about the air filtration on our machines. It doesn't matter how much filter material we put in there, we control it and take out 99% of all fines passing through. In a fan, you put more filtration in it, the less power you get at the nozzle. What's that? There we go. So there you can see us working there. That's it tipping out the sides. It tips out of the sides. And then we're back to work on site. That then is loaded up into a train. Simple process. Doesn't take any time. So this is our rail vac. This is the main machine. This is the one that does all the digging. From left to right at the top, you've got the manipulator arm. That's the one that does all the damage. That's the, oh, it keeps jumping forward. I don't know why. I don't know why. There, it's got the manipulator arm and hose. It holds 18 cubic meters of material before it has to tip. And you see there containing the two hoppers there highlighted with the two arrows. And then you've got the filter hopper. Again, it's a HEPA-type filter and traps the minutest particles, including that generated by the exhaust system. Then at the rear, you've got two cat engines. Like I said, one is to run the machine up and down the track, and the drive systems, which are as highlighted there, hydrostatic drive wheels, one at the front and one at the rear, two sets. These are, when we come into site, we're classed as just as a normal rail wagon, and then on site we're disconnected from the train. We drop the drive wheels down. We then become OTM, on track machine. The deflector plates you see there in grey, they open up, as you saw in the video previously. They open up to about 2 meters to allow us to tip the material away from the track. On the rear of the machine, I don't know if you can see in the photograph, but right in the rear of the machine there are two arms that come out. They've got an electronic beam that passes between two sensors. So anybody that breaks that beam at the rear of the machine, any plant, any person, it automatically stops the machine. And it can be fitted with, as you see there in the photograph on the bottom right, it can be fitted with dual grade laser systems to control depth, crossfall, etc., etc. The ballast feeder system that we've built, a bit like an MFS wagon. It's got an internal conveyor. It holds 45 tons, and it can feed from one machine to another. So if you've got a rake of 10, you'd have one like that we've got here with the conveyor at the front, which we can swing in an 180-degree arc and reach 5 meters out from the track and along the track. Hydrostatic drive wheels the same as the rail vac, so each unit can be independently moved under its own power. The operator just flicks a toggle and it moves uses a remote control kind of unit, and up and down the track it goes. So you don't have to leave it in a rake. It doesn't have to be hauled by the train and moved by the train. So you can do various activities within a work site, loading out pea gravel, loading out other materials, sand, pea gravel, ballast, whatever you choose, loading spoil. It also has a built-in water-fed dust suppression unit on the front there, holds about 2,000 litres of water with a fine mist spray. So when we're discharging new ballast, it gets sprayed with the water and it doesn't create any dust. So it's a good thing, you know, with silica dust and all the issues that we have with dust masks and generating dust on site. So it's a pretty good machine. Both of our machines can work under live overheads. There's no restriction on our EAC, and both machines can work ALO with an adjacent line open. So they were designed specifically for the UK business to open up 7-day-a-week working. Instead of utilising big long blockades at the weekend, we can go in and perform on any given day, night shift, no matter how short. We can always produce something, and we're very, very productive. So we can just carry on midweek nights. Track's never broken, no disconnections at all from any line side equipment or cabling. Much easier than utilising RRVs.
Not sure if you can see the hands, Steve, but I think Richard had a question there.
Okay, sorry, I didn't see it. Where's it gone? It's gone back now. Thing jumping about. Right, where are we? Yes, who had the question? Sorry, Peter.
Hi, Steve. It's Rich Daly. I'm the track section manager at Stoke-on-Trent. I just wanted to ask a question before I forget. So you might be in the presentation, but I know we use this. It's a long time ago. I was probably in the tech office then when we used this at Stafford.
Yeah, we did.
A good few years back, and it had to come to site basically, and then be sort of tracked on site. So
yeah, that was our old machine. That was our
right. That's what I was trying to ask for.
Gauge machine.
Yeah, so this can come in on the rail from start to finish, so it doesn't have to be transported on the road like it used to years and years ago.
Absolutely, mate. That's how it was developed. You see, we had the original machine that came to us because it was so new in the UK. It was a UIC gauge machine, so technically it couldn't run on the open infrastructure, so it was too big. So we used to have to build wraps like we did in the sidings at Stafford. That's a few years ago. That's about 2006 or 2007.
Yeah, mid 2000s. Yeah, that's what I remember. You see, because I remember the problems. The problems, but I had to get around stuff, especially in and around the station area at Stafford and whatnot. So I was just considering that really. So it does sound good because.
But yes,
I'm thinking myself really for like we do sleeper slides with RRVs and it's quite labour intensive. So this now, if it's within W6 gauges, looks really good. Yeah.
Well, this machine, we can go through it later, but you'll do in an hour. You'll do 6.5 meters of track to 300 mil below sleeper bottom.
Yeah.
In plain line. So wet spots, we do. In 3 hours, you'll do a track length really easily.
Right. Yeah.
So it's a different machine. I had an input in its design. Told what we need for the UK market. Like I said, so we did it. W6A gauge. Yeah. So it can work under live overheads and it can work with an adjacent line open. So it ticks all those kind of boxes, Richard.
Yeah. Thanks for that information. That's
all
great.
Right, buddy. No worries. And the spoil handling, as you saw in the video earlier, it tips out the side currently, and some people don't like this. They term it as double handling, or they don't like the spoil going back on the track side, etc., etc. Typically, we'd bund an area with the terram as you saw there, or dig a trench in the 6-foot area, and keep discharging the spoil. We get back excavating, and RRV then loads it up. But the ultimate goal is for us to build a spoil handling system. So on the bottom left there, these are concept drawings. We've had the one on the left is a vacuum system which will allow us to excavate more or less continually tip into a rail wagon on an adjacent line or into our ballast feeder machines at the rear of us. So working on a single line without the need for RRVs. And again, what that will do is improve productivity. We don't need overhead line isolations. We don't need to on track and get machines down to site and back again, thus cutting down the available times you have midweek. So most everything is as you know, is worked weekends only, and it's a bit of a nightmare to do. It gets ingested. The one on the right was a machine that we had built, and it worked we had it working at the Rail Life show a few years ago, where we utilised skips on a machine with hydraulic lifting arms. These skips were 9 meters long and a meter square, as you can see there, and we could hold the wagons. Then could hold our 18 cubic meters on each wagon, and they could be hauled to site, drop the bins down. We tip out of the side like you saw earlier into the bins. Train drops back, lifts them up. Simple process, but we've never actually got to this point due to You know, we've never had enough continual work to enable us to invest in the future, but ultimately that's where we want to be. This is one of my sort of big things that we need to talk about, is the quality of the excavation. Typically, when a railvac's been to site, like I say to people, it's basically a big shovel. It'll do what you want it to do. It'll dig as deep as you want it to do. It will put a crossfall on, etc., etc. But the engineering personnel have got to monitor it and tell it that it's a dumb shovel. If you tell your shovel at work to sort of dig in some potatoes and you want them 300 mil deep and you want the tops mounding off and things like that, then you have to do it. The machine doesn't do it. So basically what I'm saying is, it's the technical side of it is down to the client and the technical guys on site. As you can see there, look, again, we talk about stiffness and what do we do about compaction, and what do we do about excavating transition ramps. Well, we can do all of this. We need the transition ramps to avoid sudden stiffness change, ballast memory. As you can see, this was off a railvac site up near Scunthorpe on the top right corner there. You might not be able to see it in on your picture, but you'll see the dip there. There was no transition ramp put in. That first bed was dug at 300 mil below sleeper bottom, and that's the result the next morning after a tamp, etc., etc. I went out just to have a look at it, and this is the result. So if we don't get the ramps in, you won't get the quality required. And again, the middle picture there, depth, track bed strength, it's not consistent. You get, I don't like the term ballast memory, but you will pick up, if it's not dug deep enough, you will pick up any anomalies underneath, and that will be reflected in your top. Crossfall, we can put crossfall on, we can make sure that happens. Again, it depends on category of a track. Basically, most of the time, we're only dealing with the ballast layer, removing ballast. We're not doing a full renewal, so we shouldn't be really affecting formation levels. We should be taking out the ballast layer and putting the new ballast layer out in, depending on the category of track. But again, people tend to overdig because of scoping, etc., etc. You can end up with a rough bottom that's dug too deep, and then you don't get the right compaction. It keeps dropping off, etc., etc. It's essential that we have effective drainage. I tell our guys to excavate through the ballast shoulder. It's not very often that we've done a job where we take all the ballast shoulders off, even though we're digging out some of the worst wet spots you could ever imagine. The shoulder never comes off. We then therefore create a channel in the track. So I get my guys to basically excavate through the shoulder and dig some drainage channels into and over and above the existing drainage. We're not going to break any drainage. We're a vacuum system that can do all this kind of thing without breaking any cables or existing drainage, and it just makes it easier. And then again, with regard to compaction there on the bottom right, you can see we can install any kind of geotextile, any strengthening materials such as geogrid, geowebs, to help with consolidation, and then utilizing the Robel type hand tampers as the first phase. It really do hold the track up, as long as people utilize the hand tampers professionally. I mean, I have gangs that have worked with me for 20 years that do that, and they know instinctively. Well, you can tell when the Robel doesn't go in anymore. You've consolidated the ballast right from the base of the excavation right up underneath the sleepers or bearers. They do a great job if they're used right. And then of course you can tamp, and then you can of course you can DTS whatever you need to do for fine lining and fine tuning your lines and levels. But that's basically it. These things all need to be done to enable us to hand that track back, and then for the track to perform how it's supposed to do going forward. I mean, most of this work we do is a refurbishment. We're trying to make the track last for a period of years. If these aren't done, which as you see in that case down the top right, if it's not done, there's no way you're going to make a silk purse out of a sow's ear, I'm afraid. So this is the rail vac. Can it excavate design depth and crossfall on the plain line and S&C? Yes, it can. Oh. Can it excavate transition ramps? Yes, we can. We can install them. People say, oh, no, we can't get them in. Well, you can. There's a method that we use, and it should be used on every job. But again, alas, it's not, I'm afraid. Can it excavate the shoulder and cess? Yes, but again, very, very rarely is it ever utilised to do that job. Can we install filter or strengthening materials? Yes. Can we clean out existing drainage pits or install new drainage? Yes. Can we investigate drainage? Yes. The client needs to provide technical support to set up the laser for excavation works that we can. So like I said, we can use 2D laser systems to manage depth and crossfall. We put it on our nozzle and we can work away quite merrily. You know, the rail vac won't do this job for you. You have to do it yourself. So, and again, there's just a bit more information that other in-situ re-ballasting systems don't have the capabilities. And again, I've been out with this machine since 2004, so I see different areas, different people all the time, and it's variable around the engineering quality and delivery throughout the delivery organisations. But it needs to be standardised and it needs to be done in the right way. And it's got to be engineering quality. It's essential that we get that into this, and we can do it. And as we saw earlier, the vacuum system is more powerful than anything out there on the railway. Quad fan systems, triple fan systems, etc., etc.
I think we got another question from Rich, Steve.
Yeah, sorry, Richard.
Yeah, if that's all right. Yeah, just a question really. Can it work within steel sleepers in a steel sleeper site?
Yes, yeah. We've got a rotating nozzle that sort of breaks out underneath the system. So what we'll go through is the engineering, the bits that I've changed on the machine to enable us to achieve this engineering quality,
Right.
if it's used right. But yes, we've done lots of steel sleeper jobs.
So I've got some real bad sites and it's all steel sleepers, and we've tried to do sort of sleeper slides conventionally, and we just can't do it. You can't get the movement.
Yeah, you've got to dig too deep, and you can't get over them spade ends anyway, can you?
Yeah, that's
but the
it,
rail back, we did I don't know, about 600 yards up at air on a steel sleeper site.
Right, might be worth me getting some information off you then for my engineer to pass on, because we've really struggled with this site, and we've had cyclips up, we've had ESRs on it, TSRs on it. It's a real problematic site, but knowing that this kit could potentially do that is another good thing, really.
Oh, absolutely, absolutely. Yeah. You just contact me and we'll come out and have a look and sort it out for you.
That's great. Thanks, Steve. Cheers.
All right, Richard. No worries. So again, this is how we construct the ramps. Basically, mark out the ramp length, whatever it's going to be. Most people stick to the standard. Oh, let's just put a 5 meter ramp in. So we mark it out, calculate the number of sleepers. 5 meter ramp, you're talking about seven sleepers or something like that. 7, 8. Mark the original positions of the sleepers on the tracks. You can see there in the yellow marks. And then the track personnel. Then if you remove the clips, he's gone back again. They remove the clips, take out the insulators if they're there, and any pads, then put the old clips back in. The rail vac then will dig to the depth. So if you're taking it over 7 sleepers, it's 300 divided by 7. You're talking 40 odd millimeters increase in depth. So from 0 down to 300 mil over 7 sleepers. So he'll excavate to the required depth, and then what he'll use is nozzle then just to bump that sleeper, because it's got no bearing. If you need a jack in there, we just ease it with a jack. He bumps the sleeper up, and then he can take off the stools and maintain that rake down into 300 mil. He pushes the sleepers back. The ballast then automatically starts coming in behind us. So as soon as we've got 3 or 4 bays done, that'll be filled up, start filling up with ballast. The guys then will row bell it off. We put the jacks in, take out the old clips, new pads, new clips and new insulators, and then we carry on with the 300 mil. It takes about, for a 5 meter ramp, it takes about 20 minutes to do this. So there's no extra on the time at all. No extra on the timings. But people tend not to do it. They give a show at it. They'll try and put the rozzle underneath the sleeper and say it's been undermined, but it's not good enough. Depth and cross-pull control, as you can see, 2D laser system. There's on the rear of the nozzle there, you can't see where the operator's looking at there. There's another remote sensor on the back that picks up from the front, so you can put 2 or 3 around the nozzle, and you've got sight of what the lights are doing, whether it's too deep, too shallow, or spot on. So again, we can control the depth to cover another engineering question, and there improve the cut surface. We use the rozzle. This is a rotating nozzle there with a tooth on. It fits underneath the sleepers, helps to remove any kind of stool, smooths out the dig, and keeps the nozzle vertical so that you can control the depth of dig a lot better and give you a smoother cut. And you're not over digging. So if you want to dig 150 mil on a siding, or 200 mil on a cat 2 track, or cat 1A at 300 mil, then this allows you to do it. That's what we're saying. This is how we've improved the machine since we first had it back in 2004. And again, results of poor quality. This is a job again. This was up near Hull. This was the day after. This had been re-ballasted, and there'd been some maintenance. There'd been some refurbishment done through the bearers, etc., etc. And when they can't improve the track quality on this, the first thing they say to me is it was a rail vac job. Then people tend not to use the rail vacs. But this is the day after we'd re-ballasted through this set of points. You can see the new ballast there. And yeah, again, these are all the failures: lack of machine excavation control, lack of proper consolidation management, no ramps, no alignment design. And again, they put new timbers in on the heels of these, and you can see the alignment is a little bit poor. So the rail vac digs out ballast, but you have to tell it how to dig it out. And I see this quite frequently. I must have 1,000, 2,000, 3,000 photographs of poor track that's been done under refurbishment. So the rail vac can't line that rail up, that's for sure. And again, consolidation. It's difficult to consolidate when you're doing track in situ, but like I said, when you use different materials like geogrids, geowebs, and basically if you do all the put all the ramps in, etc., and you've done put the alignment right through the S&C as you've refurbed it, your track geometry should be fine. It should be absolutely fine. I've handed track back to 80 mile an hour just with row-bells. As long as you monitor and keep an eye on things, it's quite easily done now. That work on a job at the weekend, walk away from it, think you've renewed it, and nobody ever maintains it then for another 6 months. It's not really the best thing. So again, it's about, we usually put void meters on, manage the voiding, if any. The most we've ever seen the track drop is 8 millimeters. We've never seen it drop below 8 millimeters. We've never had any incidents where we've had a poor twist due to the rail vac, etc., etc. But consolidation is one of the engineering questions that we get asked about. But again, if we do the job correctly with the tools that we've got at hand, you should never ever have a problem. So that's basically the engineering quality side of things. And then I'm just going to talk a bit about the versatility. It's not just a one-trick pony. It cuts across all disciplines on the railway, as you can see there: electrification and signalling, drainage, maintenance, plain line, S&C, civils. So it digs a 1.5 meter cubed trial hole in 5 minutes. Yet we still have tens and 20s of guys going out there digging 1 or 2 holes a night, every night. Drainage, it can excavate 40 meters of drainage per hour. We can drop the drainage rates down by about 50% currently, and down to about 70% if we build our new system. Plain line, as I said, 6 to 10 meters per hour to 300 mil below bearer bottom, sleeper bottom. We can do that. S&C, C9.25 crossover, we can excavate, reballast that in anywhere between 8 and 12 hours. A D switch, again, 12 to 14, and so on and so on. These are crossovers, not just a point end. But this is where we have a problem going forward. It does all this, but each one of those rafts of work, switching, crossing, plain line, track maintenance, I'd have to sit with 6 people of the same area on the same route that may have jobs within 200 yards of each other, and I would have to go back and do 6 jobs where we could do them all together in a blockade or all together in midweek nights. So like I said, we're suited to working 7 days a week. And here we've got the activities. Can we do this? This is basically, you know, we for Network Rail, for the industry. Reballasting, do we do this? Yes, it's used in the UK. Reballasting for plain line refurbishment, not as much as we like, although we are getting more and more jobs. Replacement of sleep bearers under S&C. We don't do any. Manpower still digging it out by hand. We can excavate a 24-foot bearer in less than 9 minutes with 2 cribs and underneath it in less than 9 minutes. Refurbishment of drainage, we've done a few, but you know, we can, if they go out with the jetting systems, they find a blockage, the rail vac could go in there, open it up, change a piece of pipe, lower an invert, raise an invert, change a catch pit, whatever it needs. The rail vac can do that without damaging the rest of the system. Enhancing drainage, the use of DTS 400, we've done some trials of that. So all these things there, you can see there's lots and lots of there's a few yeses, but there's lots of no's. The computer's died now, it's not clicking on. So every no on there is a missed opportunity for Network Rail. You know, it's as simple as that. We need to get some joined up thinking and joined up planning, basically. And efficiency, optimizing efficiencies like this, you know, current working practice, 1 or 2 shifts at the weekend, not a lot of work midweek nights, systems idle. This is what we are. We'll do a double shift at the weekend and we're doing nothing for 4 weeks, 4 mid or 5 midweek nights. So if works delivery used our machine for 2 shifts at the weekend, you know, maintenance could have it for midweek nights, etc., etc. But it's not used, I'm afraid. And again, optimizing it, reballast S&C at the weekend, you've got wet spotting, you've got drainage, all these things that we can do, as you saw on the previous sheet, the previous slide. And here we have, this is us working with line side cabling. In Sweden, they don't bury the cables in, they don't put the cables in ducting. They just bury them out of the way. And with the rail vac, because you're not going to damage them, you can open them up. They never get stolen in Sweden, that's for sure. So, and you can see how gentle the machine is. Since 2004, we've never broken a cable or a service that's been attributed to the rail vac on any of our sites. So basically what the job they're doing here in Sweden is they're locating existing cables and then they'll move them or bury them or install a new cable prior to any bank profiling or machinery or digging, excavating, track renewals, etc., etc. In Sweden, Trafikverket know exactly where all their cables are, because we go out there, we find them, we plot them. Basically, we know how far away from the track they are, we know how deep they are, and we know the diameter and type of the cable. So he's just lowering the track now. So when they do the renewal work, you can work quite easily. We've done quite a bit of work locating geotextiles with high output, but it's like with any renewal or high output systems, if you know what you've got in the track before you start, then, and you know there's no problems once we've been out there, then you can work quite merrily without striking cables, any bridge decks and things like that. We can excavate those. So it's a simple thing for us to do. Again, that was signalling drainage opportunities. We're not used on drainage, but we've proved that we can really improve productivity and reduce costs where we've been on there. And these are all the things it can do, you know, maintenance and refurbishment, installing new drainage tracks, enhancing the drainage on a lot of these jobs. You know, it is overlooked, I'm afraid. It's all right going digging 600 meters of plain line if the drainage is no good, but we can, along with the re-ballasting. And again, structures, trial holes there. We did working on the in Wales, down on the Cardiff Valley lines. We were doing a 1.5 cubic meter trial hole. Eventually, when they got their end of things in, we were doing them everyone in about 5 minutes, 10 minutes. Drainage trenches, we were doing 5 meter trenches from the end of the sleeper out from the track out into the cess, locating all manner of services. There was a high voltage cable they didn't know was there. There was a gas service they didn't know that was there. But with the Railvac, we located them. Everybody was happy then. They knew where they were, and they couldn't keep up with us with design when we were doing the trial holes for the overhead line structures. We did one job down there, and then they decided to bring the manpower back in, and they were doing 1 and 2 a night with the 10 or 20 men. So that's a quick run through. So in the summary, the Railvac is the most powerful, our Railvac, Railcare's most powerful and productive, cost-effective system that's available to the UK rail industry, without a doubt. It's a proven method. We've been re-ballasting S&C since 2004 and plain line track. And like it says there, we've been serving Network Rail for 20 years this year. It was designed for a 7-day working, although it's never been utilised. It's very versatile. And again, its versatility is not optimised in the UK. There's no joined up thinking, there's no joined up planning. So therefore, the opportunities are missed. Work is currently focused on weekend possessions, so the higher rates and the production rates are sort of minimised by that. Although we are, you know, on a 24-hour weekend shift, you know, we can knock out some re-ballasting for sure. We'll do a D and E crossover in 24 hours. We do need more focus on delivery of work over the week. And, you know, then we can improve productivity and reduce the costs. And at the bottom there again, it requires greater collaboration and planning across Network Rail. We'll give the support, no problem with that at all. We do it now. But yeah, it's a great versatile machine, and it's underutilized. And that is the end of the presentation. So if anybody's got any questions, please let me know, and I'll try and answer them as best I can. Thank you very much.
I've got a question, Steve. Has
Yeah.
the Railvac ever encountered any soil or material it can't get through? Any like really stiff clays or anything like that?
No, not in track. Like I said, with clays, we've dug blue clay down in Didcot and around that area in Three Bridges. We've dug China clay down in the southwest. There's nothing stopped us at all with in track. We've even excavated glued ballast. So inside the track envelope, we've encountered nothing that we can't dig. It'll even break up sandstone. It won't, of course, it won't touch the harder rocks, but it will. It has excavated sandstone up in the likes of around Rotherham and Sheffield Station. So yeah, there's nothing. It increases the power. Like I said, when we're digging out clay, it'll go into the clay and pull out big bungs, whereas the other systems, the fan systems, the power dies. So then you've got to manually agitate the track with water or with air lancers. So it's yeah.
That you mentioned 93% vacuum. Is that the standard operating pressure, or is that peak when it gets?
No, if we left it alone, it's not 90%, 90% of a vacuum. So we reduce it to 80% of a vacuum. So that's what it runs at. It's about 19,000 cubic meters of air per hour that flows through the nozzle. It can lift on vac power itself. It'll lift just about lift a concrete sleeper.
Bloody hell.
Yeah.
So just a question regarding the filters.
Yeah.
How do they work exactly? Is there a, like, what do they look like? Is there like a steel mesh filter down to a finer mesh and then fabric later
It's
on?
in the rear of the. Let me just flick this back up if I can. Where is it? Let me just find it again for you. In the rear of our machine.
I was just wondering with regards to reliability, like do the filters ever get clogged up if they're going through?
No.
Lots of clay or
no. That nothing, because the heavier material drops straight into, as you see in the machine there. When I go to where's the machine where it's got the highlighted there for you? There. You've got these. I don't know if you can see my cursor, but there's two sections at the front there. They're the material hoppers. In that rear hopper there's filter membranes, a series of filter membranes that sit down, and as the air is pulled through here, all the heavy material drops there, all the dust, etc. then is taken through this filter system before it's out there into the air again.
Right.
So it's in there. It's like they hang like curtains in there, big, the width of the machine basically, and they go from sort of, I don't know, a bit like geotextiles right down to real micro mesh HEPA type filters at the back. But again, like I said, we've got that much power. It doesn't stop us from working, excavating the clays, etc. But like I said, a fan system, the more filtration you have in it, the less power you get at the nozzle.
Yeah.
You see, so like I said, a fan system, if you're 100 meters with a long tube away from the main unit, you've probably got a third of the power that you've actually got when you're right on top of the machine. Whereas ours, we could put a 200-foot nozzle on the end of our machine, or a 300-foot, and the airflow is constant. It doesn't reduce any.
All right. Bloody hell. Any questions from anybody else?
Hi Steve, it's Rich again.
Hi, Rich.
Just a couple of it. I think it probably self-explanatory, but I'm assuming it can work in channel drainage. The nozzle's small enough to get in the smaller channels that we have.
In channel drainage?
Yeah.
Yeah. We'll clear out about, I don't know, 200-300 meters an hour.
Right.
You just have to put the. I mean, even if the nozzle don't fit in it, we've got smaller nozzle, but I mean, we usually have a 225 nozzle or an 8-inch or a 9-inch nozzle, and it starts sucking out the material as you hover over the top of it. But yeah, we've done lots of channel drainage. I mean, we use the machine which is taking off the concrete tops as well. We cleaned around the edge of the drainage and cleaned out the channel drain, and we were doing 350 meters a night in a normal midweek night shift.
All right. So can it sort of work without having the manpower to take, because when we normally do it, you see, we normally take the lids off so many shifts before, which is a slow process. Is that something else that can be speeded up with this bit of kit, or is it the same sort of thing? We need
Oh
need
yeah,
to
yeah,
prep
yeah,
it with.
yeah. Let me just I have got just give me a second.
Okay.
I have got some
I mean, another quick one. Are you on Coombe then, Steve? I assume.
no, we're not on Coombe. What you do is
Right.
we have to we are oh this is channel drain, look. I'll show the video.
Yeah.
You'll order us off of Enroll. So you'd have to
Right.
order a train. We
Yeah.
order the loco. We'll come on the loco.
Yeah.
And it's ordered through, but I'd come out to you and say, right, okay, you've got X amount of drainage to do or wet spots or whatever. And I say, it's going to take us this long to do it.
Yeah.
I'll produce you an estimate. See him there, look.
Oh yeah.
I'll produce you an estimate. And then you produce a PO. But what we want to do is get this machine working 7 days a week. So then it becomes like an RRV.
Yeah.
So if we get X amount of shifts per week, per year, it makes it easier for you guys and you know, do what you want with it. Well, other than that, we have to, it costs.
Yeah, costs more because
Costs more money, yeah.
Well,
yeah.
like I say,
Although the machine, you know, like I said, people say it's expensive. The machine will cost £6,500 for a midweek shift, but then they say, well, you've got to have a loco on. But what they don't look at is we're doing 30 wet spots a night in a normal 3 hour in another normal 5 hour possession.
Yeah.
So the unit rates come down massively. I mean, wet spots. I don't know how much it costs you to move a wet spot with an RRV.
Yeah, I mean that's what I need to look at now and look at because
Yeah.
like I say now I know it's more versatile as well, and
see 'em
everything
there,
else.
yeah.
It's like working out because I know now we struggle because we have to work with isolations and this happening with the RRVs.
That's
But
right.
if your sort of kit can work under live,
Yeah.
as well, then we're probably going to get more productivity out of that shift than we do what we're doing at the moment. So I think we really need to start looking into it in more.
I've just done some price comparisons for doing it traditionally with an RRV and the slotted bucket, as you say,
right.
and with the train materials and our ballast feeder, etc.
Yeah.
And I can tell you now that we're over 50% less unit costs.
Okay.
50%. And if we have a spoil handling system where we can work without, I mean, you'd probably still have to have an RRV on, but even working with one RRV, all the RRV is going to do is going to come to site, load up the spoil. We'll have been digging for 2 hours. We'd have had out 20 wet spots in 2 hours. He's got to come down and load the spoil, and then we attach to the train and go. So you're improving, even with the cost of an RRV. It's still massive amount of reduction in unit rates.
Yeah. Like I say, we need to look into it more. I don't really network rail, especially now. It's like I say, it's a different kit than we thought it was years ago.
I can share
definitely.
that information with you, Richard. There's no problem with that, mate. It's not, I'm doing it for hopefully trying to get to the Rams and the route directors with this kind of information.
Yeah, if you can share some information, that'd be great. I mean, you might still remember my engineer, Mike Lewis. He's still at Stafford, so he's probably keen. Yeah, Mike's still at Stafford as the engineer. So if you can share anything over to Mike, that'll then obviously be in touch with me, or vice versa, then that'd be great because we've got a lot of drainage work, and obviously I can see some other uses for it as well on sites that we've not been able to tackle before. So yeah, definitely if you can, that'd be great.
All right, I think I've still got Mike's number. I don't know if it's the same number, is he?
I would have thought so. Yeah. Right, thanks, Steve.
He was only a young fella last time I saw him. I bet his age since he's been married and got kids.
Probably, yeah.
All right, Richard. Thanks, my friend.
Cheers.
Any questions from anybody else? No, I think that's possibly it then. Right.
Okay.
Steve, I think stuff like this is absolutely fantastic. It's interesting just to actually watch it work, and as you was playing the videos, then just how you it's demonstrated out there, just lifting that trough lid up like it was nothing, and pretty much just sweeping through and just cleaning the entire thing out.
Yeah.
It's interesting to see where it started out. Interesting to see where it's come to now. It's developed along the years. Just to reiterate what Peter was saying at the start of the meeting, we're looking for some additional section committee members. So again, you can, you've got any interest in that or know anybody that's interested, you can email through at cheshire@thepdy.org. Again, next section meeting is on the 4th of April. That's under the regular timetable. Otherwise, I'd like everybody to either unmute the mics and thank Steve for this amazing presentation, or drop something in the chat. Yeah, thanks very much, Steve. It's been a good talk.
Oh, thank you, Lee. Really appreciate it, and thank you guys for giving me the time and your time. So really appreciate it. And like I said, I'll send over the information if you need anything, Lee. I'll send it to Peter. Copies of the presentation. If anybody wants to take it forward and use it in anger, then they're more than happy.
Yeah, I think you might get a lot of benefit out of sharing more of these videos, just how quickly and how easily that thing operates, because I think people are a bit skeptical seeing it lift a sleeper, just knowing what it can do.
Yeah.
Right.
It's hard, isn't it, to tailor a presentation? It's really difficult to try and get things in, but yeah, I can show lots and lots of videos, but like I said,
Yeah,
doing drainage and that, yeah,
just for advertising from your company's perspective as well. I think it's just shows off its power, what it can do.
Yeah, but I put lots of videos on LinkedIn anyway, so there's always plenty to see on there.
Lovely. All right,
brilliant.
I think that's it, and I think we'll wrap it up there.
All right, and Lee, well, again, thank you for your time, mate, and thank you guys, all of you, and hopefully we'll see you soon, mate.
Lovely stuff indeed. Thanks again, Steve.
Thank you. Bye. Bye.
Cheers all. Bye-bye.
Bye. Bye.